Hello everyone, my name is Luca Baiotti and I'm an associate professor at Osaka University. I work in theoretical physics, especially with Einstein's theory of gravitation, generativity, and gravitational waves. But I also have many other interests. For example, languages and linguistics is what first aroused my curiosity about Japan when I was a physics doctoral student at CISA in Trieste, surrounded by several Japanese researchers. Later, I moved to Japan with a JSPS fellowship to do research in physics at the University of Tokyo and Kyoto University, and finally I joined Osaka University. I would like to briefly introduce my research topics by giving keywords that may stimulate your curiosity. Einstein's theory of generativity, roughly speaking, states that gravity is a manifestation of the fact that 1. Matter modifies the shape of space-time. We say that matter tells space-time how to curve, and that 2. Matter, when not under the effect of forces unrelated to gravity, moves on the straightest possible path on such a curved space-time. In a flat space-time, like on a sheet of paper, the straightest paths are straight lines, as everyone knows. But, for example, the Earth and the Moon tell space-time to curve in such a way that the straightest lines are approximately ellipses, and this is indeed the familiar shape of the orbit of the Moon around Earth. If matter tells spacetime how to curve, then when matter moves, the shape of spacetime changes. Such a change starts from the region where the moving matter is and propagates away. Gravitational waves are this propagation. Gravitational waves are very weak, so we can measure only the gravitational waves produced by the densest bodies that move at the highest speeds. Among these, I have been interested in neutron stars, which are the densest material objects in the universe, having a mass up to about twice the mass of the Sun, but included approximately in a sphere of radius 10 kilometers. Some neutron stars are in pairs, called binary systems. Namely, two neutron stars closely orbit each other. In time, their distance shrinks, and at some point the two stars may merge, in what is one of the most violent events in the universe, also related to gamma ray bursts and other electromagnetic emission. I've been doing numerical simulations of binary neutron star mergers in order to compute their emissions and their fate, probably a black hole, with a goal, among others, to find information on the state of matter inside the neutron stars. The conditions present inside neutron stars are not found anywhere else in the universe, and so matter in there may have forms rather different from the protons, neutrons, and electrons of which ordinary atoms are made. Gravitational waves are very difficult to measure because they're very weak. But since 2015, we have a few detectors that can measure them. The main detectors are in the US, in Italy, and in Japan, and I am a member of the collaboration for the construction and operation of the Japanese detector, called KAGRA. These gravitational wave detectors are huge. They are made of tubes a few kilometers long, inside which laser beams are shot and reflected. KAGRA is special among these detectors because it is built underground to minimize the influence on the instrument of natural vibrations of the ground, and because the mirrors reflecting its lasers are cooled to ultra-low temperatures to minimize the influence of unwanted mirror motion on the reflections of the laser. As a conclusion, I would like to say that, in addition to research and education, I believe that the role of people like me is also that of favoring the blending of two rather different cultures, Japanese and Italian, or European. Hopefully stimulating evolution in the global society towards a better world by highlighting and merging the best aspects of each of the two cultures. Merging neutron stars and merging cultures. Ciao.